Assalamualaikum. My name is Muhammad Asfar Yusuf. My matric number B0922200038. We are 5 members of group, which is me, Muhammad Asfar, Wafa, Ain, Faris and Aizat. And our program is BMMW 1/2. So I want to give some introduction about our project, which is force and factor of safety analysis from actual structure. And we choose the roof by main of our project. So our project aims to develop our understanding of the building structure by understanding the tensile and compression strength of construction materials and force distribution in a truss. A truss is a 3 or more member construction that is typically seen as being thin or high at the joints. A list of trusses is depicted in the image below. When the load is applied to a truss, the joints allow each individual member to be in either pure tension and compression. So we were assigned to work in groups of 5 to do a precedent research on a particular truss roof. We were able to comprehend how the truss design may impact the distribution of forces by examining the connections and member orientation. We had to develop and test a truss roof after performing the investigation. So this is a FBD of the roof. The each length A until E is 1.5 meter, and the forces for A, B, C is 120 kilonewton. The force of B and H is 50 kilonewton, and the force of D from the side is 120 kilonewton.
Equation of equilibrium have 3 equations. First, Fx. Second, equation of Fy. Third, equation moment. First, equation Fx equal to 0. Fx negative 120 negative 50 equal to 0. The answer is Fx equal 170 kilonewton. Second is equation of moment equal to 0. Moment A negative 120 multiply 4.5 negative 120 multiply 3.0 negative 120 multiply 1.5. 4.5, 3.0 and 1.5 is distance. Equal to 0. The answer is 1080 kilonewton meter. And the last one equation is Fy equal to 0. Fy negative 50 negative 120 negative 120 negative 120 plus 1080 equal to 0. Fy negative 50 plus 7020 equal to 0. The answer equation Fy is negative 14.4 kilonewton. Next is joint D. This is free body diagram of joint D. Force 50 kilonewton and 120 kilonewton. Okay. Calculation of joint D is first equation Fx equal to 0, negative 120, negative FDC equal to 0. The answer is FDC is negative 120 kilonewton. Second calculation is Fy equation equal to 0, negative 50, negative FDH equal to 0. The answer FDH is negative 50 kilonewton. The next joint is joint H. Okay. This is free body diagram of joint H. The force is 50 kilonewton and negative 14.4 kilonewton. Okay. How to find degree? Degree in CGH. Calculate tan. Formula 1.5, distance 1.5 divide 1.5. The answer is 45 degree. Okay. Calculation of joint H is first Fy equal to 0, negative 14.4, negative 50 plus FHC sine 45 degree equal to 0. And then FHC sine 45 equal to 64.4. Then FHC 0.7071 equal to 64.4. FHC equal to 64.4 divide 0.7071. The answer FHC is 91.08 kilonewton. Next equation is Fx equal to 0, negative 50, negative FHG plus 91.08 cos 45 degree equal to 0. Negative 50, negative FHG plus 64.40 equal to 0. Negative 50 plus 64.40 equal to FHG. The answer of FHG is 14.4 kilonewton.
Hi, my name is Muhammad Farid Zikri. So today I will show you guys the calculation for joint C. So sum Fx equals to 0, negative FCB minus 120 minus 91.08 cos 45 degree equals to 0. Then we got negative FCB minus 120 minus 64.40 equals to 0. So the final answer is FCB equals to negative 484.4 kN. That's for Fx. And then Fy, sum Fy equals to 0. The calculation is negative FCG minus 120 negative FCG minus 120 plus 91.08 sin 45 degree equals to 0. Then negative FCG minus 120 plus 64.40 equals to 0. So the final answer for Fy is FCG equals to negative 55.6 kN. That's for joint C.
Next joint is joint G. This is free body diagram of joint G. The first is negative 55.6 kilonewton and 14.4 kilonewton. Calculation of Fy equal to 0 is FGB sine 45 minus negative 55.6 equal to 0. FGB sine 45 plus 55.6 equal to 0. The answer is FGB equal negative 78.63 kilonewton. Next calculation is Fx equal to 0. Negative FGF minus negative 78.63 cos 45 plus 14.4 equal to 0. The answer is FGF equal 69.99 kilonewton.
So next, I would to continue my part, which is to find a joint B. So we use the same method like joint F, which is at y-axis we have 120 kilonewton and degree theta 45 degree. So at y-axis have many unknown. So we like to calculate at x-axis, which is sigma. We use sigma fs equal to 0. At y-axis we have negative 184.4 minus FBA plus C minus FBA plus bracket negative 78.63 cos 45 equal to 0. Then we calculate the bracket. We had negative 55.59. That we calculate that negative 184.4 minus FBA minus 55.59 equal to 0. So we got FBA which is negative 239.99 kilonewton. So when we got FBA, we can calculate the y-axis, which is we use sigma Fy equal to 0, negative 120 minus FGF minus bracket negative 78.63 sine 45 equal to 0. So we like to settle what in the bracket, which is 78.63 sine 45. We got 55.59. So when you just calculate for Fy, which is negative 120 negative FGF plus 55.59 equal to 0, and got FGF negative 64.41 kilonewton. Bismillahirrahmanirrahim. My name is Muhammad Amirul Aizat bin Tamizi. My number matric is B0922200046, and my part is joint F, where is we use sigma Fy equal to 0. at y-axis we had negative 64.41 kilonewton, and and degree at FFA sine 45 degree equal to 0. Okay, so we calculate and I get 64.41 plus FFA sine 45 equal to 0, and I just and I calculate that sine 44 degree, which is 0.7071. So FFA is negative 64.41 divide 0.7071, and I get FFA negative 91.09 kilonewton. So at x-axis we use sigma fx equal to 0, which is negative FFE negative bracket negative 91.09 cos 45 degree minus 69.99 equal to 0. Okay, so I calculate the bracket, I got 64.41, and we use the same method, which is negative FFE plus 64.41 negative 69.99 equal to 0. So we get negative 5.58 for FFE. Oh, sorry, negative 5.58 kilonewton for FFE.
For joint A shows the free body diagram FBD of points A, B, and E, which is at angle of 45 degrees, which we calculate from the angle done. Here it shows that line B is negative 239.99 kilonewton, which we have calculate at joint B. For the count of negative 91.09 kilonewton, we have calculate at joint F. To find the joint of A, we subtract negative 120 kilonewton minus FAE minus I take joint F 91.09 sine 45 degree, and the final answer is negative 55.59 kilonewton for the value of joint A. For joint E shows the free body diagram for A and E, which is 5.58 kilonewton and 64.41 kilonewton. For the final answer, we took the value of E plus FEA, and we got the answer is negative 64.41 kilonewton. In conclusion, our final model testing, we archived the highest efficiency we have done. Our roof archive an efficiency of 120 kilonewton. This project has allowed us to understand load distribution in a Schroeder as we were able to calculate and identify the type of force applying in each member. It has been a great experience working together with my friend on this project. Thank you. Bye.
Hi, so my name is Muhammad Farizikri. So this is our poster, force and factor of safety analysis from actual structure. As you can see, this is our structure, and free body diagram for joint analysis. Here also we got all free body diagram for all joint. As you can see, joint D, H, C, G, B, F, A and E. Okay. That's all.